Hi, welcome to Code and Play. It's been a long time since I have uploaded any videos. Well, the reason is my laptop that I usually record videos on has corrupted and most of the data is completely gone. I can show you this. So as you can see, most of my data that I had, all the videos that I recorded and all the notes that I made, everything is gone. So it took me some time to recover all that, and this is why there were not many videos. I didn't make any videos in this time span, and also I was working on something else. I'm working on my personal projects, some games, some projects. So it took me some time out, and yeah. So I will try to make as many videos as possible. In the meantime, we will see something new. Since we have lost all the previous data, I recorded at least 2 videos previously. I kept them to edit them just to like add some context or in case if I made any mistakes, like I just want to edit those videos, so I kept them aside. But unfortunately, those files are gone, so I have to like record them again. But since the files are gone, well, I can record something interesting, something different. So as this is a new one, this is a completely new project, this is a completely new so today I'm going to explain you a very interesting thing. What I'm trying to say here is I tried to make this project in the previous videos. I think in the code venture I tried it, but I couldn't do it, so I had to stop the series in the middle. But this time I will start a new series and I'll show you everything about this side of the code. Okay, so let me show you what I'm trying to say. So since this is a new video, the previous video that I recorded has been deleted, completely gone. So I'm going to make a new video, and the concept is server client architecture. We usually use this concept for making MMOs or games for online or MMO games like that. We use this kind of architecture mostly in Minecraft. If you have seen Minecraft or Roblox or RuneScape Classic, OSRS, old school RuneScape. So those things are actually built in Java, and most of them are still using this architecture, server client architecture. Well, the concept here is very simple. You have a server and you have clients, right? This is client 1, this is client 2, this is client 3. So all these clients request from the server. Let me explain in a different way. Okay, so we have right. So we have a server here. Let me increase this size. Okay, so see this. We have a server here and we have clients. This is client 1 and client 2 and client 3. Okay, each of these clients are linked to the server and they send some request to get some response. For example, the client 1 is trying to log in. The client 2 is trying to load a map. and the client 3 is just walking on the map, so it's like roaming. Okay, so three different things are happening on three different clients. How does the server know which client is doing what, or how does the client know how like if I want to say I want to log in, how does the client know where the server is, or which server to log in, or which server to connect? Or if I am doing like a map and also I'm checking my inventory, if I'm dropping an item, for example, I'm roaming on the map and I dropped an item, dropped axe. Okay, so if I dropped an axe, this axe will be added to the server and it will be showing on client 2 and client 1 if they log in. If they logged into the game and I dropped the axe, those two clients will also see that I dropped the axe. So every action that I am doing here or here or here is registered in the server and it is immediately updated in the clients. How is this working? How is all of this working? So to understand this concept, in Java we have two things. In Java we have TCP connections. These are nothing but sockets. Okay, you have a server socket and you have a normal socket, which is basically a socket. So clients uses this and server is on this. Then you have UDP connections. UDP means user datagram protocol. It's a different kind of way. Here we don't have sockets, we have datagram packets. These packets are handled from server through datagram socket. Server will receive datagram packet. Okay, so in this connection we have packets, whereas in this connection we have sockets. So in TCP, which is also called a stated protocol, it is like you can say if you connect to a server, the server will have a session ID of you. For example, in this case the client 1 is logged in, so the server will have a session ID of client 1, C1. Then if the client 2 is also logged in, the server will also have a session ID of client 2, C2. Okay, as well as C3. So each session ID corresponds to individual clients. Server knows this through the session IDs. As soon as the client logs out or closes, the session ID is gone. So immediately as soon as the server is closed, the session ID is gone. Okay, so if the session ID is gone, the server only serves the remaining two. So this connection will be terminated. This is called TCP, Transmission Control Protocol. It happens through session IDs. Session IDs are what we call as cookies. In website or web pages, we have cookies. Cookies are basically session IDs. They store session IDs. Server will know which client is linking to the server through these cookies. Okay, we can do all this in Java using TCP connections, using sockets. So these two are the classes that we should use. Then we have UDP connections. UDP connections basically means stateless connections. Stateless protocol. This doesn't have any connection. There is no link or no record of any ID or any client. It is a simple, it's like you say the server is on, link to it, send the data, and disconnect. That's it. So this is one type of protocol. It is a protocol where you just connect to the server, send the information and disconnect. You don't expect anything return. If the server wants to send you something, it will do the same. It will just connect to you, send the information and disconnect. It is like a stateless protocol. There is no persistent connection in between you two. Okay, so this is persistent and this is transient. Persistent basically means it lingers for some time, and transient means it doesn't linger, it just does the task and disconnect immediately. This is why it's called stateless protocol. So we use this in Java using these two classes. Well, in games most of the times we use this because most of the time we have to stay connected. In case if you are disconnected, you will see a disconnected concept. Like for example, while playing games in PUBG or Call of Duty, if you get disconnected, you will see the message, right? So you must be connected to enjoy the game in case of MMOs or online games. This is what they are doing. So in Minecraft or in like Roblox, OSRS, this is the background that's going on. Okay, server socket and sockets. So you have a client that has sockets, you have server that have server socket. I'll show you how it works. Then we have this one, datagram socket and datagram packet. This is a very interesting thing. As I said, this connection doesn't linger, it just connects, send information and disconnect. So in this case, we are not having any connection, permanent connection or any lingering connection. So what we do is, in case of sending any data, for example, say update, like you want to update your position on the map. So you connect to the server, send the position, new position and disconnect. The server will then connect to other clients, will send the data to them and then disconnects. So it's like sending and receiving updates. It's like this. Let me explain. So you are the client. Let's say you are a player. Player moved from x equal to 10, y equal to 20 to x equal to 11, y equal to 13. So you moved in this way. Now this is a kind of, you can say, update, right? You have to update the server. Now once you want to update the server, you simply send this information. What the information is like this: previously it was 10:20, now it is 11 and 23. Let's say 11:23. So the server will send this information, will forward this information to other clients. So immediately your character on other clients will move this much. And in the same way, if someone else, let's say your name is John, okay, you are John, you are not John. For example, your position is 4,6 and John's position is 10,20. So John's new position is 11,23. So this information will now go to the server and it will forward it to your client. So immediately your client will update according to the information. Now John is at 11:23. So in John's client, if the John keeps moving, your character, that means in your client, the John in your client will also keep moving. As soon as the John in John's client, let me explain. This is correct. This client 1, this is client 2. Okay, this is you and this is your friend. Your friend is moving and let's say your friend moved to 15. Immediately he sends this update to the server. Server will forward this to you, and in your position it will update. So now you will see that your friend moved to 15. You are not seeing John as it is right now. You are seeing John few seconds ago where he was. Okay, this is called datagram socket, datagram packet. This is called UDPs. UDP is basically used to update positions, update any like states of an object. For example, at tree, there is a tree in the client one, that is your client. There is a tree that you are attacking. Okay, the tree's health is right now at 10. John will also see the tree whose health is also at 10. You attack the tree now became 0. So immediately your client will send this information to server. Server will update the information to everybody else, and they will also see health equal to 0. Okay, so this is how we use this protocol, UDP protocol, to send and receive information in a fraction of seconds. Okay, so these two are the type of concepts that we use in server client architectures in Java. When you talk about server client architecture, we use these. So how do we use this? Let me show you a small example of TCP protocol, and then we move on to UDP. First we'll see TCP. So in this case, I'm making a new program. Yeah, I have to create two separate files because I have to show you how server and client works. I'm not going to make both of them in the same project. I'm going to make two projects, two separate projects. So this is our Java server. Okay, I don't want a module, so let's finish. And we have a Java server. In this, I'm going to say new class. Package is com.suman.game server, and class. Okay, this is I'm using sockets. So this is TCP server. Okay, TCP server main method. So new TCP server, public TCP server. Okay, since this is a server, I need to have server socket. Server socket. Okay, let's say S socket equal to new server socket, and this here we have to give a port. Basically the ports starts from 0 till 65,005, I think 565 or something, 525, something like that. So it's a very huge number, but most of the sockets are already in use. For example, I'm using this one, OBS. So this is using a socket. I'm using Chrome. This is using a socket. I'm using Paint. This is also using a socket. So most of the sockets are already occupied. I'm also using some background services like, for example, if I'm using like OneDrive, it also have a socket. So every sockets are mostly occupied. The only free, some are free, mostly are occupied. So we use the regularly used ones. For example, this is a local host socket 8080. We don't recommend this for public use. This is basically for local host. That means in the vicinities, in the private hosting. Okay, so 8080. If you want a separate port number, you can also use something bigger like 49954, something like that. It's a big number. Okay, should be within 65,535 or 525, something like that. It's a huge number, so should be within this range. Okay, I'm using 49594 593 something. This is the port. Now once you import this, it looks like this. Now there is a error exception. The exception is socket exception, actually IO exception. Now we have a socket, we have a server socket. We need to connect the socket, we need to connect this server socket to a client. So for that, first of all, as soon as this socket is created, the server will say, okay, the server will say server started. Okay, so so as soon as this socket is created, the server will start at this port number 49593 something. Okay, if that port is already occupied, you will see an exception. For example, if I start this, yes, select all. Okay, so right now it is started, but if I start this again, see what happens. It's already running. Oh, it's already closed. Okay, it's already closed. Let me keep it in a loop so that it will wait. Okay, in this loop, I'm saying socket S. This is the client. This is where the client links. Okay, socket S equal to S socket dot accept. So now this socket is where the client connects. So now if I'm loading this, you see the server is started and it is already running. It is still running. Now if I load this again, since the port is already in use, you can see already in use. Okay, so if you are using any used port, you will see a exception like this. But since there is no exception first time, let me close those and restart again. Okay, so let me restart this server here. So I'm server started. So now that the server is started, server is waiting for a client. As soon as the client connects, the server disconnects because I didn't say anything to do. So as soon as it's connect, the server disconnects immediately. Why? Because there's nothing to do here. I didn't say anything to do here, so it won't do anything. Just connect and disconnect. That's it. So we'll keep this server on. Now we will need a separate project for the client. A new project. I'm saying Java client. Okay, here it is. Java client. com.7.game client. Okay, this is a TCP client. We can't cross connect. We have to use TCP connections. If you are using TCP connection, you must use TCP connection. TCP server, TCP client. If you are using UDP, you must use UDP server, UDP client. You can't cross connect. Okay, so both of them must be of the same category. Category must be same. You can't cross connect. New TCP client. Okay, so we have a public TCP client. Now in this we need a socket, of course, and this is the client socket. This socket will connect to the server like this. Okay, here we have to give the server IP address. The server that I am running on is right now running as the local host. It is in the same system that I am using. If I am having the server somewhere else, I have to go to CMD, open CMD, and type ipconfig and see the IP address. Okay, so this is the IP address 192.168.0.104. This is my system's IP address. It changes every time, it changes. So in this case, I'm using a Wi-Fi, so it changes. If I use a Ethernet, it changes. It's a different IP address. You are not running the server in the same system. You have to run the server in separate system. So you should think like this. Server is a separate system, separate machine, and client is a separate machine. Okay, they are two different things. They are not same. Your phone has a different IP address. Your tablet has a different IP address. Your PC has a different IP address. Laptop, PC, tablet, phone, hard disk, like for example, hardware like headphones, mic, everything has an IP address. If you're connecting them through Wi-Fi or Bluetooth, they will be connected through Wi-Fi and Bluetooth, and they have their own MAC addresses as well. IPv4, IPv6 addresses. If you know about this, you understand what I'm talking about. If you don't know, you can search Google, search what is IP address or what is MAC address. You will understand. Okay. So right now I'm in the same system, so I'm using localhost IP, which is 127.0.0.1. This is localhost IP. If I am going for a separate server, separate machine, then I have to enter the IP address here, like 192.56.20.1, like this. Okay. So if you are working with the network and IPs and everything, you understand. Most of the time, this part is done by network admins. We just ask them the IP and they will give the IP to us, and we just enter the IP here. That's it. Easy. Next, the port. What port is the server on? So 49593. We enter this here, 49593. Now we have the port, we have the server IP address, try catch. Yeah. Now the server is connected to the client. So server is already running. You can see here, server already started, right? It's still running. There is a terminate button, so I have to stop it manually. So the server is still running in the background, still online. Now I just connect the client and click start. As soon as I click start, it connects and disconnects, because I didn't say anything to do, so it just connects and disconnects, and immediately you can see the server also responded. How do I know it responded? Well, we can try here. We can check here. If it is connected, we will see the server connected here. Whatever the socket code, that is like which IP you're connecting, which host you're connecting, everything will be showing here. Okay, s.get port, which port you're connected to, or you can say get inet address. Okay, so you will see which inet address you are connected to, which address you are connected to. So right now, if I execute again, you will see the local host. You connected to the local host. What about server? You can also do the same thing in server. You can also see which client is connected to you. For example, I go here and I say if connected, right? Once it is connected, now I'll say system out s.get inet address. Okay, you will see which client is connected, and you can also see the port. At which port? s.get port. So the client port, it will say the inet address, the address of the client at this port number, right? So once we save this and we stop the server, close everything, and again start. Server started. Go to the client, connect to the server. The server said server started. This client connected at this port number 58443. This is the client port number, not the server. Server is running at 49593. Client started at a separate port number. If I connect again, okay, client connected, but what about server? The server is again a new client connected here. See, the server is listening. Server is looking at all the IP addresses and the port numbers. So this is called a session, right? This is called a session. Session means server knows which IP address is connecting to, which host is connecting. Like it has a record of everything. It has a record of all the clients that are linked to the server. If the client disconnects in the middle, the server will try to attempt to reconnect. Okay, this is why we set true. We set the server to true so that it accepts the client and will try to reconnect if there is a disconnection. So this is like a perpetual connection. Okay, so this is what it means by stated protocol. Stated protocol means a state will be available for the server and client. Once the client disconnects entirely, then the state will be destroyed. State means session. Session will be destroyed. Once session is destroyed, the client socket will be closed and a new socket opens up. Right now session is destroyed because I am not doing anything here. I'm just printing it and just closing it. So session is destroyed as soon as it's connected. It connects and then destroyed. For example, if I said like print 10 numbers. So I said for int I equal to 0, I less than, let's say 11, I plus plus, and I said system out I, print 10 numbers, and it will print 10 numbers and then it will disconnect. Okay, is it on? Yeah, it's on. So let me see the client now. Let's start. So now you can see it started, it printed 10 numbers and then disconnected. Now if you go to the server has a new connection. See, the previous one is gone. Previous session is gone. A new session started. New session came out and the new client printed 10 numbers and disconnected. Now if I again do this, a new session will start. A new client connection will happen. So this is how sessions happen. This is called sessions. Every client will connect and disconnect. When they connect, they have a session ID, and when they disconnect, that ID is gone. This is called TCP protocols, transmission control protocol, where you are controlling the transmission, controlling the information, the message, the way the connection is working. You're controlling everything. This is called TCP. Okay. Here you have a connection, you have a way to know which connection is going where, how, and how long the connection is working out. You have a lot of things to do here. You can say, for example, s dot, you can see connect equals get channel, get inet address, keep alive, get local port, OOB inline, option output stream port, remote buffer, reuse address, send buffer, so linger, get so linger. It means returns -1 returns implies that the option is disabled. The setting only affects socket close. Okay. So is there? Yeah, is closed, is connected. There are a lot of things here. You can see, right? Keep alive, set keep alive on, set performance, set receive buffer size, send buffer. Okay, TCP no delay. No delay basically means there is no lag. Yeah, a lot of things. Okay, so there are so many things you can do with this protocol basically. So this is what we do in TCP. You connect, you set the server first, then you wait for the client to connect. Once the client connects, they can send information and you can read the information and you can do something with it. So let's see how do we send and receive information between server and client. Now that you understand that servers work like this, let's send information. First of all, I want to say hello server from client. So as soon as the client is connected, the client should say hello server. How do we do that? For that, we need streams. Since it is a connection protocol, since it is a stated protocol, you have a stated connection, you have a fixed connection. in the fixed connection, imagine the fixed connection as a wire. In the wire, you can send information through streams. Okay, let me explain here. So if you have a connection between client and server, that connection is like a wire, electric wire, or you can say what do you call that, the wire that is used for connections, communications. So you can say it's a optical fibers. Yeah, so you can also say it's an optical fiber, or it's a copper wire, anything. It's just a wire that is having that is connected to the two ends, client and server. Through this wire, you can send information. You can send information through optical fibers or through copper wires. So in the same way, you can send information here through streams. Okay, back. So we can send the information through streams. What is a stream? Stream is a continuous flow of data like this. Buffered reader. This buffered reader will take inputs continuously. This is why we use this to read strings, because string is a continuous data, continuous you can say it's a chain of characters. So to read this chain of characters continuously, we use a stream called buffered reader. Okay, if you want to print a string, we use print writer. This is what we are using as system.out. When you say system.out, out basically means this, print writer. System is a class in Java that has a print writer object, which is out. It is a static object. That's why we say system.out. And in the print writer, we have a function called println, printline, which writes strings. So this is also a stream. Understand? So print writer have this function called println, and we are calling this println through an object called out from system class. This is why system.out.println. This is basically print writer's object. Print writer is a writing, or you can say output stream. Buffer reader is a input stream. Like that, we have file reader, file writer, input stream, output stream, things like this. Okay, so these are streams. This is how we use streams in Java. What I'm going to do here is I'm going to pass strings. So I'm going to use these two classes. So let's see how we pass strings. So the message here is hello server. This is my message, right? This is a string. So as you can see, it's a string message. So how do we pass this string to the server? To write something, to give something, we are giving output stream. In this case, the output stream is print writer. Okay, let's say writer equal to new print writer. Now, where is this output going to? This output is going to the server. So we have to establish the server. Sorry, we have to establish a connection between server and client. We already did that. Let me explain properly. We are sending an information from client to server, right, through sockets. So by using a socket, I am sending information from client to server. So I will send the information, send the string here, send the strings through sockets. How? S dot S means socket. Okay, s dot get output stream. So get the output stream from the socket and write into it. Now we'll say writer dot println. What to print? Message. That's it. Done. This is how it is. So you establish a socket, you connect to server, and then you print something in the socket. So once the socket connects, it prints to server. In the server, what we are going to do now? We will read that information. As soon as the client connects, we will read it. Let's say buffered reader. Okay, reader equal to new buffered reader of new input stream reader of, where are you reading from? You're reading from socket. So s dot get input stream, because the data is in the socket now. As I said, we are transmitting information through sockets. So client will write into it and server will read from it. Okay, client will write messages, server will read messages. How? String msg equal to message equal to reader dot read line. That's it. So server will read the message and print it. What? Message from client msg. So let's see now. Is it on? It's on. Let's close this. Close everything. Okay, first we start the server. If you started client first, there will be error. It is saying connection refused. Why? Because there is no socket to connect to. Server should start first. Server must start first. This is why once you start the server, now you go back to client, and as soon as you connect it, there is a connection risk. Oh, sorry. Client again. What happened? Connection refused. Okay, server closed. So start the server again. Server started. Start the client again. What's happening? Client is closed. Server is also closed. Connection reset. Okay. Oh, I forgot. Yes. I forgot to say one thing. It's very interesting. See, in streams, we have a concept like this. Strings basically work like this. When you're typing, when you are writing something, for example, say hello server, right? String never stops like this. It always, first of all, writes them into a buffer and then wait for your command to flush it. Why? Because this is how strings work. Strings are a chain of characters. They are not a single value like integer or float or double. They are a chain of characters. So they first write into a buffer and wait for flushing. Once you flush the buffer, then it will print. Print writer has a auto flush mechanism, which I forgot to start. So here it is, print writer comma true. Once I said true, it is auto flush. Let me show you this. So you can see I'm using this. Okay, I'm using this print writer, output stream, and then boolean auto flush. So once you auto flush, or if you say, let's say like this, s dot get output stream, and then you message, then you have to flush it manually like this. Okay, if you don't want to do it, if you don't want to do this manually, if you don't want this to do manually, you can put auto flush true, true. Now it will automatically flush the output stream and it will send the information. As I said, strings always write themselves in a buffer and wait for you to flush the buffer. Once you flush the buffer, it will go to the server. Okay, so this is true, or else you should write like this. This line is compulsory. If you don't want to write like this, you can set the auto flush to true and it will automatically flush the string. Now you can see this one is closed. Okay, so once you start the server and you start a client, you will see message from client, hello server. In server, I'm in server right now. What about the client? The client is already closed because the client's work is to send information. It's not to read anything. Just send and disconnect. That's all. So right now the server is seeing the hello server. If I run another client, one more time, hello server again, one more time, hello server again. So every time the client starts, it sends a message and closes. Okay, this is how you send messages and this is how you read messages. So once the server read the message, server will write something, server want to send something, server will use the same thing. Print writer equal to new print writer of s dot get output stream comma true. Okay, so once the server read the message, it wants to say message to equal to hi client. So what do you do? What do you do here? You simply say writer dot println, print line message to. That's it. So the server read the message and sent a response. Okay, so the response will go to the client now. Now the client has to read the response. So for that, the client will accept the input. Buffered reader equal to new buffered reader of new input stream reader of s dot get input stream. Okay, so once the server sends you message, you read the message. What do you read here? Reader dot read line. So you read the message. Let's say server message. You read the message and then you print it. Message from server. What is the message? Server message. Okay, so now we made some changes. Let's stop the server, close everything and restart. So once I restart the server started. Now I start the client. So as soon as the client starts, you can see the client sent a message to the server. It said hello server. The server sent a message to the client. It said hi client. Now client is closed. Server is still on. Server is still on, but the client is closed. Okay, if I send again, you can see server is still on, but the client is closed. Again, another message is sent from the server to client. So this is how we use TCP protocol. TCPs are mainly used to send and receive information through streams. Okay, you can send and receive anything For example, you have a JSON string that you want to send from server to client. You can do it. You can send JSON from server to client or JSON from server, client to server. You can do a lot of things with this concept. This is why we use this in games most of the time. Okay, this is TCP client and TCP server. You have streams here. You set up a stream, and using that stream you send and receive information. Mostly strings, because strings travel faster. If you are sending integers or float, they might take some time, but strings travel faster because strings can be easily decoded and encoded. That's why. Okay, so once everything is done, you just close the server, close the socket, and here also you close the socket. It's got close. That's it. So once the socket is closed, session ends. Okay, so this is our server client concept. Next video, I'll show you how I use this TCP or UDP protocols to send information like login, character data, inventory information, load a map, like that. I'll show all these in things using this server client architecture. So as we learn this more and more, we understand that Java is actually much more fun, much more interesting. Okay, so this is it for today. I hope you understand. A lot of things are very new to so many people. I tried my best to explain as much as possible, and if you still couldn't understand anything, you can leave a comment in the comment section. Thank you. Okay, and I'll upload this files into my GitHub, and I'll leave a link in the description. You can go to the link and you can see these programs. Okay, fine. I hope you learned something new. Thank you.